Oh, hello there, I didn't see you. I'm glad you could join us. Welcome to Uppsala Biomedical Center. My name is Anders Edlund and I was born and raised here in Sweden, and I'm currently studying biotechnology and business and administration here at Uppsala University. And I first became interested in synthetic biology about 2.5 years ago when I first participated in iGEM, which is a big international competition in synthetic biology. And last year I was actually the project leader for the Uppsala iGEM project. And it was during this time that I thought about the idea that I would like to bring to the SynBio accelerator. And it has to do with the genetically engineering zebrafish. But before I continue talking about that, I think we should go to where a lot of the work that we're going to do is going to be performed at. Hi again. Now we are at the zebrafish platform here in Uppsala, and as you can see here behind me, there are lots of tanks filled with zebrafish that researchers are currently working with. And it's mainly in the field of developmental biology, but there is a very broad range of expertise here that will definitely come in handy for the project. And as you might have already seen, the idea is to genetically engineer these to let them express different kinds of fluorescent and chromoproteins. And I have a couple of images here with me from a newly published paper that shows what that could look like. So that's basically what it could look like when we engineer them. But of course, what's going to be different from these is that ours will be able to change color by inducing and repressing the genes that are responsible for the colored proteins, and that the customer will be able to control this themselves. And there are many ways in which one could do this, but the most promising that I have found is to couple it to their feeding. So for an example, you could take a regulatory sequence for a galactosidase enzyme and couple it to the genes for these colored proteins, and it would induce expression of these genes in the presence of galactose, and it would repress it in the absence of galactose. And this would also have the advantage that we could sell special kinds of fish food that would contain high and low levels of galactose, and this I think could prove to be just as lucrative as selling the actual fish. Okay, we are back at Uppsala Biomedical Center. So you've heard a little bit about me and about my idea. I think it's a pretty unique one and has quite a lot of potential, not just in being able to turn a profit, but also in being able to spread synthetic biology to a much wider audience, since our customer is going to be the general public. And with this project we will be able to bring synthetic biology into people's homes, where they will not only be able to view beautifully colored fish, but they will also be able to participate and get a sense of control when changing the color back and forth. And I hope this has awakened your interest, and that I will be able to join you in Cork later this summer. This is Anders Edlund, Uppsala, signing out.